everybody, welcome to Video Notes 4.1. We're going to look at ionic compounds, so get ready. Chapters 4 and 5 are parts of what you have to know, so do this stuff, okay? Answer this question. Just to review, electronegativity helps us decide what's going to happen to electrons. If an atom is very electronegative, it pulls the electrons all the way off the other atom, and that's when you get an ionic bond. So ionic bond is transfer of electrons because one atom, the non-metal, is more electronegative than the other atom, so metals lose their outer electrons, non-metals gain, and that makes an ionic bond. You get oppositely charged things. So what do these compounds have? They have high bond energies. They have high melting temperatures. They're hard, brittle materials. They're insulators. They don't conduct when they're solid or electricity or heat very well. But when you dissolve or melt them, they do conduct. Okay, so many are soluble in water and some are not. And we'll talk about why. But this is very different than covalent, and so are some of the other properties. Okay, so what holds an ionic bond together? Remember those two words, electrostatic force. That's attraction between oppositely charged ions. All right, hope you like the joke, the cartoon. All right, so what can we do to see if a substance is ionically bonded? Well, we can bring down the hammer, hit it with a hammer, and because ionic bonds involve positive and negative ions lined up alternating, if you hit it with a hammer, you push the negative ion next to a negative ion, and then it breaks along those lines. Okay, so right here, it would shatter and break and not bend at all. Okay, so this is a reference to something really old like me. Can't touch this. Okay, so here is a model of ionic compounds and their conductivity. Okay, so when you put electric current through an ionic solid, it does not conduct electricity because the ions are stuck in place. Look at that pattern, repeating pattern, crystal lattice structure. When you run electric current through water, it does not conduct electricity because the water molecules are bonded together. Yes, they're polar, but there's no current that can flow. But when you mix ionic compounds with water, the water tears apart the ionic compound into its charged particles, and now these charged particles can move freely, and the light bulb turns on. Okay? So ionic compounds conduct electricity when they're dissolved because the ions can move, and ions are charged complete a circuit. Okay? So why do they bond at all? Because valence electrons are used in bonding, and if the metal gives its outer electron to a non-metal, then the metal's outer shell becomes full because it clears out the outer one, so then it's a full inner shell, and the non-metal's outer shell becomes full, and you get a full charged ion, cation and an anion, and so they're held together by electrostatic attraction. Same thing with lithium and fluorine. Hey, I have an extra outer electron. Hey, I only have 7. Give me yours. Woo, yay. And then we get this opposite charge, electrostatic attraction. Ooh, look at that nice handwriting. Oh, thank you. Okay. So ionic bond is transfer of electrons from low electronegativity to high electronegativity and makes charged ions, and the opposite charges attract. Okay. So one thing we can look at is called Coulombs law. Here's the formula for Coulombs law. Go ahead and write it down so you know what each thing means. Right? And then we'll look at why some things, how we can use this to help us decide about properties of ionic compounds. Okay. So here's the attraction of positive ion with a negative ion. Positive, negative, positive, negative. Right? Coulombs law again. So if you look at this data, you see that NAF, right here, NAF, has the positive radius and the negative radius. So here's the positive radius, R1, and here's the negative radius, R2, we'll call it. Here's the negative and positive. The distance between the atoms is 231 picometers. Okay. Wait, I drew it on an ACL. The 231 is center of that atom, negative radius, positive radius, 231 picometers. Right? Sodium chloride, this here to here, is boom, C76 picometers. So what does that mean? Well, let's look at their energy. The lattice energy of this bond is 908 kilojoules per mole. The lattice energy of that bond is 788 kilojoules per mole. So as the radii get bigger, the lattice energy gets smaller, and the melting point is lower. Okay, so what does that mean? That means the smaller the ions are, smaller the radius between the positive and negative ion, then the more energy it takes to melt them. So it's a stronger bond. So let's look at here. Here's radius, right? If the radius is small, then that means this is going to be big, right? Because this is small. So then the charge stays the same. It's a +1 and a -1. It's a charge. So small radius means big force. Okay, see if you can agree by looking at that data. So this is a little hard to read, but you can see when it's red, the red parts are the ions, and then either the yellow, purple, orange are atoms. Okay, so we have yellow atom. When it turns into an ion, it gets smaller because they lose electrons. Over here, we have orange atom. When it turns into an ion, it gets bigger because it gains electrons. Okay, so you can see how atomic radius is these colors versus ionic radius, which is the red. Okay, so what does it mean? To talk about bond strength, we're going to use two factors. The smaller the ionic size, so smaller ions, the closer they are to each other and the stronger the bond. The higher the charge of an ion, the more attraction there is between the ions, so the stronger the bond. So two factors influence bond strength. And so that's what Coulomb's law says. Let's go back to Coulomb's law. Which part of this is the charge? Charge. So that means big charge equals stronger force. What part is this? This is radius, distance between atoms. Smaller radius equals higher force. So that's these two things in words. We'll keep talking about it. So, ionic compound properties because of Coulomb's law. Some ionic compounds dissolve in water when the attraction of the water for water is stronger than the attraction of ions to each other. So when Coulomb's law formula multiplies to a total of less than 4. So the charge of ions is less than 4. When 4 is greater than the charge of the ion, so that's less than 4. Okay. Then they will dissolve in water because water is more attracted to the ions than the ions are to themselves. Now, they do not dissolve in water when the attraction of the ions is stronger than the attraction of the water. So when you multiply the charge, positive times negative charge is greater than or equal to 4, then there's going to be insoluble, do not dissolve, because the ions are more attracted to each other than they are to the water. Okay, we'll practice. All right, so what do we call the ions? We got to put in some rules. Okay, ions are the same name as the metal, but without the word ion, but with the word ion. So potassium ion is K positive. Magnesium ion is Mg plus 2. You may be saying to yourself, so where am I getting these charges? Periodic table, the ions they form. Anions are named like the element, but change the N in the name to ID. Example, chloride is Cl with a negative. Nitride is N with a negative 3. How do I get these charges? Periodic table. I remember +1 group 1 group 1, +2 group 2, skip a few. +3, 0 for that column, they don't make ions. -1, -2, -3. Okay. What ion will sulfur form? -2 ion because it's in this group. Lithium, +1 ion because it's in this group. Bromine, -1 ion because it's in this group. Okay. So between elements in compounds and ions, elements only one type of atom, compounds 2 or more types of atoms bonded together, but they're neutral. And ions are a group of atom or group of atoms with a charge. So, what's this? Elements, because it's the same type of atom. Element. Okay, this one, compound, because there's two kinds of elements and there's no charge overall. This one, two kinds of elements, but it's got a charge, so it's an ion. This is an compound, because it's got more than one. This is an ion. This is a compound. This is an element. Now, many atoms with a charge is polyatomic ions. That's what you're memorizing. Right? So, carbonate, hydroxide, carbon dioxide. Why? No charge. No charge. So it's a compound. So, compound. Right? So be careful. When you see it by itself, you get charge ion, charge ion, charge ion. Ion, ion. Not an ion, no charge. Okay. Here's some rules for eights and ites. So you memorize chlorate is ClO3 negative and chlorite is ClO2 negative. Look at the number of oxygens. So what would perchlorate be? It would be ClO4 negative. And what would hypochlorite be? ClO negative. Okay. So, oh look, he ate more chicken because he's Jabba the Hutt. He ate more chicken. Okay. Polyatomic ions are groups of atoms. Group of atoms with a charge bonded with overall charge. So, how are they held together? Well, you got your bonds, covalent bonds, all over the place, but then overall charges. So these are resonance structures, and there's a -2 overall charge. Hey, you have to memorize them, so I put them here. Ionic compounds, you have to look to see what it starts with. So this is a metal, and this is a non-metal. So this is an ionic compound. How do I know it's a compound? Because it's two or more elements bonded together, and there's no charge overall. Again, ionic compounds. You got a poly and a poly.